Hi everybody, Sarah Minson here. Today I'm going to be doing my lesson on pH and the pH scale. This would be about a ninth grade biology lesson, so maybe 10th grade depending on when the school takes it. But pH is an important part of that. So we're going to do the pH and the pH scale. And so to get started, I'm going to talk about pH and what the pH scale is. The pH scale is actually a measurement of how acidic or basic something is. And it's a scale of 1 to 14, 1 being the most acidic or your strongest acids, like things like nitric acid, sulfuric acid, all the way to the strongest base up at 14, things like sodium hydroxide are strong bases. And in the middle at 7 is neutral. So neutral is water. Water is not acidic or basic, so that's right in the middle. So let's talk a little bit about water more and how that plays a role in pH. So water, as we know, is H2O. Probably everyone knows that. H2O, water. Water is actually called a polar molecule. So what does that mean, polar? Polar means that it has positive and negative sides. So the oxygen is a little bit more negative and the hydrogens are slightly positively charged. That's because the electrons in the molecule spend a little bit more time around the oxygen than they do around the hydrogen. Because electrons are negative, that makes the oxygen slightly negative charge and the hydrogen is a slightly positive charge. How does that come into play when water gets together with itself? Well, let's take a look. So when you have water molecules together, it's just like when magnets attract with the opposites, north and south pole. Think of it like that. Oxygen's got that negative charge and the hydrogen has a positive charge, so they're attracted to each other through hydrogen bonding. And those are really, really strong forces. So when we take something like hydrochloric acid and we drop it into pure water with those forces, hydrochloric acid has positive and negative charges too. The hydrogen and the chloride have their own charges. So when they go into water, they dissociate. Hydrochloric acid breaks into hydrogen ions and chloride ions. The hydrogen's positively charged and the chloride is negatively charged. And so the water is actually reacting and wanting to be attracted and pull those apart as well. And we'll take a look at how that happens. So here's a bunch of water molecules, and you can see they're going to pull these apart. They're going to aid in this dissociation in the water. All these oxygen atoms are going to pull and be attracted and kind of gather around this positively charged hydrogen ion, okay? And same on the opposite end, and that's how that works. So if an acid is really strong, it will dissociate or break down almost completely in the water, and that's where you get the stronger acids. If it doesn't really break down that much, you're going to have weaker acids. See, there's only like one hydrogen there, just for simplicity's sake. So how do bases work? Bases dissociate in water too, and the water gathers around the positive and negative atoms in those elements, or the positive and negative ions. So for example, you take sodium hydroxide here. Sodium and hydroxide, the OH breaks off into its own negatively charged ion, and the sodium breaks off into its positively charged ion, and the water would gather around it the same way. So for bases, the more OHs that are built up into that solution, the more basic it is. Whereas for acids, the more H pluses that are around, the more acidic it is. And so this is just the basic, showing you in simple terms. The more H pluses you have, it's going to make it more acidic. The more OHs you have, the more basic it's going to be. And you can test this at home. They have pH strips and things like that that you can dip into different solutions and it'll turn colors. It'll turn red if it's a really strong base, blue if it's a really strong acid. But if you don't have that, you can make this cabbage juice at home by getting a head of red cabbage, breaking up the leaves, boiling it, and making solutions. And then you can put drops of unknown liquid or anything you want to test. And based on this color scale, it'll tell you if it's an acid or base. So I've done that. That's a pretty cool experiment. So until next time, keep experimenting, keep learning, and that is all I have for you guys today. Thanks.